Welcome. You're watching First Principles AI, where we prioritize depth over trends and understanding over hype. So, you built an AI demo that looked like a pure magic, and your team was blown away, and your boss was ecstatic, and all the charts shot up and to the right. But the second it met the real users, it quietly and confidently started to fail. If this sound familiar, you are not alone. This is the story of a great divide in the artificial intelligence, the massive chasm between a sleek prototype and a production system that actually works. And the failure rate is staggering. Recent reports from groups like MIT have found that up to 95% of the generative AI pilots fail to deliver a real world impact. And other industries estimates place the general failure rate for AI projects at around 80%. They all die in a place we call pilot purgatory. So, why do models with 94% accuracy in the lab completely fail apart in the wild? It's not because the model was a dud, and it's not because the tech is a lie. It's because the demo was an illusion. And in this video, we are going to unpack the three silent killers that cause this to happen. And more importantly, what you can do to make sure your project is one of the rare few that survives. The illusion of perfect demo. You have to understand that a demo and a production system are playing two totally different sports. Your demo lives in what we can call as a still world. It's like a land of clean, curated data, often a single perfect CSV file where every problem has been conveniently scrubbed away and where the data is static and also the environment is controlled. The goal here is simple: get the highest possible accuracy on the data set that never ever changes. On the other hand, in the production, it's like a moving world. Data isn't a file, it's a fire hose. It streams in from dozens of live sources. It's messy and it's incomplete. And it can change its entire structure without giving a warning. For example, it's like a tennis player who spent months practicing against a partner who only hits perfect shots down the middle. The moment they face a real opponent who serves, volleys, and plays the whole court, all those fine tuned skills are suddenly useless. In the still world of Jupyter Notebook, a model hitting 96% accuracy is a hero. But in the moving world of production, the same model is a liability. If it takes 5 seconds to make a prediction, or crashes during a traffic spike, or costs a fortune to run, production doesn't just care about accuracy. It cares about stability. It cares about latency and cost and reliability. The tragedy is that we optimize for demo, not for the messy, chaotic reality of business. We build to look good but not to last. And that mismatch is the first step into the graveyard. Coming to the section 2, the three silent killers of production AI. If the demo is a mirage, what are the concrete things that actually break the model in production? It's almost always boiled down to three silent killers. These are the real problems that never show up in a notebook and almost never gives you a clean error message. They are systemic failures that cause perfectly good models to slowly degrade and die. The silent killer one, data drift. The number one reason AI fails in production is something called data drift. Simply put, data drift is a rude fact that the world changes without asking your training data for permission. The data you trained your model on is a snapshot of the past, but the world has keep moving and new trends pop out of nowhere. Think about it. A model trained to predict retail inventory in 2019 learned its pattern from a pre pandemic world. If you deploy the same model today, In a world of hybrid work and the online shopping surges, what do you think happens? The input data, what people buy, when they buy it, and from where, has been fundamentally changed. The model, however, is stuck in the past. What makes data drift so nasty is that it's a silent killer. The model doesn't crash and it won't throw an error. It just keeps making predictions with the same unblinking confidence as always. But those predictions get more and more wrong. Without constant monitoring, the model's performance quietly decays day by day until someone in the finance finally asks why the AI that was supposed to save millions is now making $1 million mistakes. Unless you plan for the world to change, your model is guaranteed to become a fossil. The second silent killer, fragmented ownership. The not my problem epidemic. The second silent killer isn't about tech at all, it's about people. In most companies, building and deploying an AI model is a game of hot potato. It starts with the data science team who lives in the experimental world of notebooks. Their job is to build a model with the highest possible accuracy, and once they hit their number, they toss the model over the wall to machine learning engineers or data engineers. And this team's job is to make it run in production environment, and then they wrap it in an API, stick it in a container, and push it to the cloud. Then they hand it off to the business team, the people who are actually supposed to use it. So, when the model's performance is inevitably starts to drift, who owns it? The data scientists say, hey, it worked on my machine, must be on a deployment issue. And the engineers say, the API is running just fine. The model's logic is a black box to us. And the business team, they just know it's not working and stop trusting it altogether. This lack of end to end ownership is where AI projects die. No single person or a team is responsible for the actual business outcome. And when nobody is watching the whole system, from the raw data pipeline to the final prediction and its business impact, nobody notices when it starts to silently break, and when everyone is only responsible for their tiny pieces of the puzzle. The system as a whole is set up to fail. The silent killer 3. The system is not the model. The final mistake, and maybe the most important one today, is thinking that the model is the entire system. With the rise of incredibly powerful large language models, it's an easy trap to fall into. We are seeing something like GPT-4, Gemini, or Claude doing amazing things, and we start to think of it as an artificial brain we can just plug it into our business. But a production AI solution isn't a model, it's a system built around a model. The model is just one piece of puzzle. It's just like an engine, not the whole car. A successful system needs automated pipelines to feed it clean and reliable data. And it needs a monitoring framework to catch data drift and performance issues. It also needs automated retraining pipelines to keep the model fresh. And it needs guardrails and validation layers to stop bad outputs before a user can seize them. And most importantly, it needs a feedback loop so the system can learn from its mistakes and actually get better over time. So, building a model is often the easiest part now. The real work, the work that separates the tiny friction of successful projects from the 95% that fail, is building the robust, automated, and resilient infrastructure around it. Without that scaffolding, even the most brilliant model is just a fragile liability waiting to break. By the way, learning how to handle these challenges, data drift, ownership, and system thinking. These are the core of a discipline called MLOps or machine learning engineering. It's all about bringing the same rigor and automation to machine learning that DevOps bring to software. If you are serious about shipping real AI products instead of just demos, sticking around channels like this one is a great way to learn the principles that successful teams put into practice every single day. And going to the next section, crossing the chasm, the mindset shift. Okay, so we know why projects fail. How do you avoid the same fate? The good news is the path to production isn't a secret. It doesn't require some stroke of genius, but it does require a huge amount of mindset shift from experimentation to engineering. The solution one, become a system builder, not a model builder. The first and biggest shift is to stop seeing your job as building models and start seeing it as building systems. This means you have to embrace MLOps from day one. Version everything, your code, your data, and your models. Automate your deployments with CI CD pipelines designed for machine learning. Your goal isn't to create one perfect model, it's to create a machine that can reliably produce, deploy, and maintain good enough models over and over again. The best teams treat their AI systems like an automated factory. Raw data comes in, goes through automated validation and processing, and a model gets trained and evaluated. And if it passes a whole battery of automated tests, then it gets deployed. This AI factory approach is the only way to scale reliably. Solution 2, plan for failure from day one. The most successful AI teams are a little bit paranoid. They don't hope their models works forever. They assume it will fail and they plan for it. They bake comprehensive monitoring into every single step of their pipeline. They set up alerts that trigger not when the server is down, but when the model accuracy starts to dip or when the data distribution shift past a certain threshold. They also deploy safely. Instead of doing a risky big bang replacement of an old model, they use technique like A/B testing or canary release to roll out the new model to just a small fraction of users at first. They measure its real world performance against the old one and only scale it up if it's actually proves to be better. They have a rollback plan ready to go. They don't just hope for the best, they engineer for the worst. And going to the solution 3, start small, build the foundation, then scale. Finally, you have to resist the urge to boil the ocean. So many ambitious AI projects fail because they try to do way too much too soon without the right foundation. The pressure to deliver a flashy, world changing results makes sense. Teams skip the boring but absolutely essential work of building solid data infrastructure. The smart play is to start with one well defined business problem and use it as your pilot to build a production grade pipeline. Focus more on the infrastructure than on the model itself. Get the data pipeline, the versioning, the monitoring, and the automated deployment working for one simple use case. This creates the paved road to production. Once that road is built, deploying your second, third, or tenth model becomes exponentially faster and safer. You can't build a skyscraper on a foundation of sand. Build the foundation first. The incredible AI demo of yours didn't fail because the model was bad or because AI is all hype. It failed because the demo was just one tiny piece of much larger system that never actually built. The gap between prototype and production is littered with the ghost of projects that mistook a clever algorithm for a finished product. The teams that constantly win are the ones who get that AI isn't a magic. It's a demanding engineering discipline. They are the ones who build the scaffolding, the monitoring, the feedback loop, the automated pipelines, and the culture of ownership. That what allows a model not just survive but thrive in the messy, ever-changing real world. They know that the real goal isn't a great demo. It's a system that reliably delivers value day in and day out. And that is the bridge across the chasm. If this look at the hard realities of production AI was valuable for you, make sure to subscribe and hit the bell. We are going to be going way deeper into MLOps, data drift, and system design in the future videos. Thank you for watching.